Okay, it's time to do the 2002 very famous AP free response problem called the amusement park problem. This is the rate at which people enter an amusement park is given by this function E of t, and the rate at which people leave the same amusement park on the same day is modeled by L of t. So both E of t and L of t are measured in people per hour, and time is measured in hours after midnight. So the functions are valid for 9 to 23, which means basically 9 a.m. to 11 p.m. These are the hours that the park is open. The time equals 9 a.m. There are no people in the park, which makes sense. And you would hope that there's nobody in the park at 11 p.m. when the park closes. Let's see how this works. So it says how many people have entered the park by 5 p.m., which is t equals 17. Round your answer to the nearest whole number. Well, I'm going to write up here. The number of people who have entered is going to be the integral of your E of t equation on the interval from 9, which is when the park opens, to 17. So we're going to go to our calculator and we're going to have to clear out all previous work here. And I recommend, by the way, clearing A through Z. If you are the type to save values, I don't save values, so I never have to worry about that. But if you do, save values, make sure you clear A through Z. And what we want to do here is type in the E of t function. So we have 15,600 divided by, and then make sure to put your entire denominator in parentheses in the calculator. We have t squared minus 24t plus 160, close parentheses, and again, go to the left-hand expression, and make sure it matches what you meant to type in. Okay, now we'll do the calculus. We're going to go to F3, choice 2, which says integrate. We'll go grab our expression and bring it into the line. We'll hit comma t to integrate with respect to t, and then comma 9, comma 17 to integrate from hours 9 to 17. And we get a very complicated expression that I'm going to go grab and bring into my row and hit green diamond, enter, which tells me that 6,004 people have entered the park. And notice that they did say round the answer to the nearest whole number. So the answer is 6,004 people. Okay, the price of admission is $15 until 5 p.m. and after 5 p.m. it only costs $11 to get in. So the question is, how many dollars are collected from admissions to the park on the given day? And again, round your answer to the nearest whole number. Well, we already know that 6,004 people came in on the interval from 9 to 17. Okay, so we have $15 times the 6,004 people. Plus, we're going to have $11 times the number of people that come in between 17 and 23. So 5 p.m. and 11 p.m. So 17 to 23, and that of course is E of t dt. So let's work on our calculator again. First we're going to find the integral of our entry function, our entrance function. Again, we put integral from F3, we go grab our expression for the number of people who enter, or the rate at which people who are entering, comma t, comma 17, comma 23. So this will give us the total number of people who have arrived in the park on the hours 5 p.m. to 11 p.m. Don't forget you need green diamond enter to get a decimal number instead of the arctan, etc. So I have 1,271 people came in on the hours 17 to 23. So let's do the basic math in our calculator now. We have 15 times 6,004 plus we have 11 times 1,271 people. Notice that I did round off during my calculation because I can't have a partial person. So it's okay in this case to round 6,004 and round to 1,271 while you're doing the calculation. So I hit enter and I find that we earned $104,041 on the interval from, well, on the entire day. So $104,041. Okay, part C says, and I should put a dollar sign here. Part C says let h equal, rate in minus rate out integrated from 9 to t. So that is going to be the net number of people who have entered the park. We have the rate at which they enter versus the rate at which they leave. So at any given time t, it's the net change in the number of people in the park. So they want to find the value of h of 17 to the, they're telling you, look at this, they're telling you the value of h of 17 to the nearest whole number is 3,725. Well, that means that the total number of people in the park at 5 p.m. is 3,725. So find the value of h prime of 17 and explain the meaning of both. Well, we just talked about h of 17 is the integral of the rate in minus the rate out. So it's the total number of people in the park at 5 p.m. And it is the total number of people since the initial value of the number of people was 0. So it's typically the total change, but since the initial value is 0, we can say that the total number of people in the park at 5 p.m. is 3,725. Then they want us to find h prime of 17. Well, h prime using the FTC part 2 is, well, h prime of t is just going to be e of t minus L of t. So h prime of 17 is going to be e of 17 minus L of 17. So let's once again turn to our calculator and let's start by typing in the L function because we're going to need that in a moment. So we have 9890 divided by, remember parentheses around your entire denominator to get t squared minus 38t plus 370, close parentheses, and this is my L function. So what I'm going to do is go up and grab my E function, the rate at which people are arriving, right here. I'm going to evaluate it. Actually, what I'll do is I will subtract out now my entire L function, and then I will evaluate that difference where t equals 17. And I'm going to get a fraction, so let me grab it, bring it into this row, and hit green diamond, enter, negative 380. And of course I'm going to round since this is people we're talking about. So this is equal to negative 380, yep, negative 380, and that's going to be in people per hour, because since this is a net rate, this is rate in minus rate out, this represents the rate at which people are leaving the park because it's negative at 5 p.m. is 380 people per hour. All right, part D. At what time on the interval from 9 to 23 does the model predict that the number of people in the park is at a maximum? So all of a sudden, here we are at our candidates test. So let's think about what we're doing here. We want to know when the number of people in the park is at a maximum. Well, we already know that H represents the total number of people in the park. So for part D, we are trying to maximize H of t, which equals the integral from 9 to t of e of x minus L of x. Well, the derivative of h prime, is equal to e of t minus L of t via the fundamental theorem of calculus. Part 2, I need to set this equal to 0 to find the candidates, the critical points. So we go to our calculator, and what I'm going to do is go to my graphing screen, clear out the function I had in previously, and I want to type in my E function first, 15600, divided by, don't forget to change your t values to x values to type into your calculator, x squared minus 24x plus 160, and then hit enter, and then I'm going to type in my L function, so 9890 divided by, and again, change your t values to x, divided by x squared minus 38x plus 370. And algebraically, we know that if I'm looking for e minus L to equal 0, that will occur when e equals L. So when y1 equals y2, I just need the intersection point. But again, I've got to change my window to be from 9 to 23, which is the domain of this problem. So let's take a look at the graph here and see what we see. See how many intersection points we see. Let me take a look at what I've done. Okay, I figured out what I did. I was looking at where I had a zoomed in view where I would just see right around the x-axis, but I'm not looking for a 0 here. I'm looking for the intersection of two curves. So I need to change my y min and y max to make sure I accommodate where I would see my intersection point. So it's a little bit of a guessing game here. I'm not quite sure when I'm going to get a good window. I just tried negative 20 to 20, and I don't think that's enough. If I think about it, this is going to be in rate of people. So maybe I should expand this to be, say, negative 500 to 500 on the y-axis. So let's see what this gives us and see if I can find a graph. There we go. Okay, so I see my intersection point will be right in here. Let me go ahead and do F5, and I need an intersection point. And I'm guessing first curve, second curve, and then of course I need a lower bound, which brings me to the left of the intersection point, and an upper bound, which brings me to the right of the intersection point. And it guesses for me, and it says 15.794 or 795, but of course when I do my table of values, I'm going to go ahead and plug in all four of these decimal places, 0.7948. So here are my candidates. 15.7948 is one of them. One of them is 9 for my starting value when I had 0 people in the park, and one of them is 23 when I also should have 0 people in the park. So really, I'm comparing 0 and 0 to whatever this is, so I should be able to just use my integral of h of t from 9 to 15.7948 to find the number of people in the park at that time. So let's go ahead back to our home screen, and we are going to use the integrate e of t, which is our rate of entrance into the park. Go up and grab it. Way up, there we go. And I'm going to subtract out, actually I need to open up a parenthesis because I've got an expression going in here where I'm subtracting two expressions. And then subtract out the rate at which people are leaving, which is the one with the 9890, there we go, comma, t, comma, 0, comma, 15.7948. Close parentheses, and let's find out, oops, missing a parenthesis. I believe that was right here after my expression that I was integrating. And I find that the maximum number of people in the park is going to be 5867.73. But you know what I just realized? I don't need to know that. I just need to know the time when it's the maximum number of people in the park. I did a little bit too much work. It says at what time. So the time is going to be the 15.7948, and the justification is just that I found the critical points and I know that the endpoints have to have 0 people in the park.